Alright, let's see if we have the idea here. We have here a tree. Let's call it an evolutionary tree, a simple evolutionary tree. And what big picture idea do these trees represent? In a word, if you had to pick one word, a word starting with R, what would you say? How about this one? Relationship. Relationship. Yes. And so there's the idea of relationship. And so this tree now, I've got a vertical axis and a horizontal axis. What can we say that those represent? Well, the vertical axis represents the passage of what? The passage of time. Yes, it does. Passage of time. And so the top of the tree represents what time? Yes, indeed, the present time. The present time. What about the horizontal axis? Well, I'd say it is an extremely weak representation of variation. Why extremely weak? Because it's just one-dimensional. And organisms vary in many dimensions. There's many differences between us and oak trees, that we don't just vary in one thing. But we'll just say it's a very weak representation of variation. All right, what else we have here? We have these places where the branches come together. What are those called? I think those are called what? Common ancestors? Yeah, common ancestors. And we'll have a definition of that in a second, but we can just look on the tree and see who's the common ancestor of what. The common ancestor of B and C is what? Well, let me put something on here. Let's put E, F, and G. So the common ancestor of B and C is what? E, whatever E is. And the common ancestor of B and D is what? F. That's where the branches come together. And so we can look at this and figure out if this reflects real relationships. Who's most related? What else? For example, is B more closely related to A, or is B more closely related to D? B more closely related to A or B to D? Well, B and D are kind of close together the way I've drawn it, but which ones are more closely related? Well, B and D would be. Why is that? The branches come together a little quicker, a little sooner. You don't have to go as far back in what? In time before the branches B and D come together. This would be the common ancestor of B and D. However, the common ancestor of B and A, you have to go back farther in time. That would be G, whatever G is. And so you can see who's most closely related, who's most distantly related by looking at this, at these diagrams. So we have the idea of relationship. Let's flesh that out just a little bit. Let's state it a little bit more fully. According to the concept of evolution, which species are related? Just the ones on the earth today? I don't think so. All species that have ever been on the face of the earth are related by common ancestry. And so all species that have ever been on the face of the earth are related by common ancestry. All species are related by common ancestry. What does that mean? You take any two species that have ever existed on the face of the earth, if you go back far enough in what? Far enough in time, at some point the branches come together and you have a common ancestor between the two. So what is a common ancestor? Well, it's kind of like your grandparents and the common ancestors of you and your first cousins, if you have those. And except in evolutionary terminology, or concept of evolution, the common ancestor is a species, an ancestral species. An ancestral species like E that gave rise over time to descendant species. An ancestral species that gave rise over time to descendant species. So E gave rise, according to this, to B and C. And so B and C are different from each other, and they may be different from E. At least one of them is going to be different. One may be something like E, a little closer to what E was. But the main point is they are different from each other. The common ancestor has given rise over time to these descendant species. And so that is the common ancestor. One final thing, what's the topic? Descent with modification. Now if you go back in time, you find common ancestors. As you go forward in time, you have descent with modification. Descent with modification. And so B and C are descended from E, and so there's some modification of whatever E was as the evolution of B and C took place. Descent with modification as you move forward in time. All right, that's the basic concept, and that's it.